Oh. Okay, let's come for this one. Cursor problem. Yeah. Okay, now let's say there's another bank. Shortest path. What do you mean by shortest path? You will start at at t equals 0, you'll start at A. He has to reach exactly a point on opposite bank. You should reach here. This should be the end point. So there's a river current. River current. And there's the width of the river. Velocity of swimmer should be directed like this. Yes, the same diagram I'm continuing. And this will be velocity of river. So how Vs bar should be? Vs bar should be perpendicular to this. So I'll take the same angles what we continued. No, so this was the theta we took. Let me take same theta. So this is called like a shortest path. Means you should exactly reach a point opposite on other bank. That's the meaning of shortest path here. Now time taken to cross the river in shortest path. Time how to calculate? We will determine time taken. So here, what is the basic condition? What is the expression for this? This will be 0, no? So from that, shall we write like this? I want you to, what should be 0? Vsx must be 0, no? Will I agree this? So I'll start like this here. Vsrx is equal to Vsx minus Vrx. Will I agree this? Vsrx, velocity of swimmer with respect to river. So it is what direction? Minus Vsr cos theta. This should be 0, Vrx. So Vsr cos theta should be equal to Vr. So what is cos theta? Vr by Vsr. What was our question? Time taken to cross the river. W by, we'll determine time taken to cross the river, Vsy. W by Vsr sin theta. Sin theta, what you can write? Root of 1 minus cos square theta. Substituting this, what is cos theta from here? Vr square by Vsr square. So the final answer will be W by. Okay, fine. There's a time taken to cross the river in shortest path. I'll write nearby only. This is the answer. Getting the idea? This will be. So here, what is the path? There's a path with respect to ground. And what about this? There's a with respect to river. This is what actually you have to process. You can ask question, sir, why Vsx is 0? Because drift is 0, no? Drift is 0. And why sir, W by Vsy? How Vsy equal to Vsr sin theta? Vry is 0. So go back to again the same basic way of. So what is this? This will be Vsr sin theta. That's why the Vsy has become Vsr sin theta. These are some background. So what I earlier discussed, no, that Vsrx equal to that one, that you should not forget. So this is a basic idea of the shortest path here. So two things are there in front of you. Shortest path, div 0. For shortest path, you have to swim up the stream. To cross the river in select a least time, in a shorter or select in a minimum time, you have to swim normal to river current. And whenever I say you should swim means I'm saying VSR only, not VSR, not VS bar. VSR bar only, what happened can be measured, no? So you should swim normal to river current means it's VSR only. Because this quantity cannot be measured, so we are not bothered to even indicate also. So, and even in questions also, nobody will ask you to determine them. You can't hear me. Just can you hear me now?
Sir, I changed to another device, sir. Now I'm able to.
Can you hear me?
Yes, sir.
Okay, I'll continue now. Is that okay now? So these are the time they can. So now I'll put one. Sir, if you sims up the stream, then where is the end point? End point is there, no? So can it happen? One more situation like this, where it sims up the stream and the displacement will be on towards left. Let me give last one more. So this will help you a lot in numericals. So it will start from here. This is a start point. T equals 0, it'll start it here. The river current is flowing like this. BR. Velocity of swimmer with respect to river. The river current will push him. And the VSR bar is like this. I think this is a totally different situation, no? So you look at the path I'm showing now. Where is added? This is A, this is B, this is C, this is A. This is the end point. Okay, fine. So now we have conditions like this. Yeah. Now you, what is this path I should call? Path with respect to river. What about this path with respect to ground? And it will reach in a time t. Let me write it here. Okay, now let's write expression for crossing the river. Let this be theta. So directly shall I put W by VSR sine theta? What about the drift? X equal to VSR cos theta both will be negative. Directly I'm writing. You must think on this. Negative sign, what do you mean by negative sign? Towards left. The drift will be towards left here. The swimmer, what happened, he says, I'm adding to point B, but he will end up at point C. So now look at this one. Is he swimming up the stream or down the stream? The swimmer swims up the stream. So where he is reaching? On the left side of the point B. So when it swims up the stream, what are the possibilities? He may reach, the drift will be negative and the drift will be 0, or the drift will be positive also. Able to make it out? I think we have the first few cases, no? The second case, though he swims up the stream, the drift was positive. So when he swims up the stream, what will happen to drift? Drift can be positive, negative, or 0. Is that okay? So there's one basic condition here, that one. So here the drift is towards left. So that's why the negative sign is brought here. How do I wrote this? You have to go back to your basic mathematics of relative velocity again. Okay, this is overall the core. So in a nutshell, I just wanted to, Vsy will determine time, Vsx will determine drift, finish all. And every problem, it will be like this. VSR bar is equal to VS bar minus VR bar. So this is the core idea. So don't fight with the formulas. So every particular formula which you are not understanding, start from here. Resolve this along x, along y, apply this along x, along y, and that. And we'll determine the drift, x component of velocity of swimmer with respect to ground. We'll determine time taken to cross the river, y component of velocity of swimmer with respect to ground. Okay, so in books what happened, it has become some sort of random.
So shouldn't that be plus VR? I mean minus VSR cos theta plus.
Instead of fighting with this, better go back and apply the formula rather than fighting with this. Go back to the formula. The best thing is go back to formula. So what that formula says, VSRX equal to VSX minus VRXX. No? So the drift depends on what? Let me substitute all this. What is the direction of? So this will be VSR cos theta equal to. So VRX, this will be towards right, no? This was a negative. If you take towards right, positive. So VSR bar was towards left, negative. And this is what, like, you say VR. Okay, no, I'll put it VR minus VSR cos theta. Okay, I think I should change the sign. Huh?
Yes, sir.
Plus it will be, this will be minus. Oh, so this will be negative. Okay, no. I'll write it. Here it will come. So yeah, definitely VSR cos theta will become greater than VR and X will become negative. So you leave it to the values. It will determine that particular thing. The same earlier method. So VSR cos theta is towards left, no? So take help of sign. So this should be positive. Is it okay? No? I just took help of the basic formulas. You need not to make a guess of anything. Now in your numerical, if VR greater than VSR, tell me where the endpoint will be on the right side. If VR less than VSR cos theta, then where the endpoint will be on the left side of this one. X will become negative. The X is positive, negative will determine this particular bracket term. Here I assume that VSR cos theta greater than VR. So therefore the endpoint has come on the left side. The diff will be positive, negative based on this particular bracket. So the method will be same, no? You can see here any situation. So when you're getting a question, no, you have to be very careful. If it seems up the stream, so VSR you have to assume against VR bar. So this is the condition. If it seems down the stream, the very first diagram, if it seems normal to river current, VSR bar will be perpendicular to VR. So if it seems up the stream, component of VS1 horizontal component of VSR should be against VR bar. Okay. If it seems normal to river current,